we are finding angles. So it's still using SOHCAHTOA, same formulas, but there'll be a slightly different step to try and get the theta by itself because we're trying to get the angle. Okay, so the rules, same rules as before. And here are the first few questions. So these ones, we don't have any triangles yet. I was going to show you that extra step of how do we get a theta by itself to solve that equation. Now, normally when we're trying to solve equations, we do opposites. So if we times and divides are opposites. But what is the opposite of a sine theta? No. It's a bit of a trick. I'm not really expecting you to be able to answer because you've never seen it before. The opposite of a sine theta is what we call an inverse sine. And to write it down, you write sine with a little -1 above it. Okay, so that's moving it across to the other side of the equation. So sine with a little -1 on it of the 0.6. Okay? Kind of like when we solve equations, we're doing opposites to move things across to the other side. By moving across and became inverse sine. To type that into your calculator, you have to use a slightly different button. You can't just press the normal sine button. You have to press your shift button first, shift sign, and it brings up. Okay, so shift sign of 0.6 and press equals, and that would be the angle, 36.8699 degrees. That's degrees, that's an angle. The question has asked me to round to 1 decimal place. So it would be 36.989. We have to that one. For now, yes. No, we'll start to shortcut it in a bit, so we're going to get used to it first. So let's try that again for B. To get the theta by itself, I'm going to move the cos across, which makes it become an inverse cos of the 0.35. So in the calculator, you're going to press shift cos of 0.35 and press your equals button, 69.5. That's degrees, that's an angle. You don't have to write the degree symbol though, be down for that. Doing it again for C. To get the theta, I'm going to move the tan across, which means it becomes an inverse tan of 2.1. And we type it in. Shift tan of 2.1 is 64.5. All right, do you think we can do the last three without the working line? So if I want to do D straight into my calculator, I need to press shift cos of the 0.5. Oh, that's a very nice one. That's exactly 60 degrees. So theta equals 60. Type in the next one. Shift tan of 0.46. Oops, that was the wrong tan button. Better try that again. Shift tan.
With the last.
Yeah, it works the same. It's just faster to type in. Was it 24.7, was it? Good. And last one of these, we are going to shift sign 0. For all of these ones, you have to press the shift, yes, 0.1. So theta equals 5.7. Okay, good. Next thing we're going to practice, this is another calculator practice thing, is to convert these numbers, which are in degrees, they just have a degree symbol on there, to degrees, minutes and seconds. We did talk about these quite a few lessons ago by using our bubble button, our degrees, minutes, second button. So what you do to type it in is you just type the number 34.23. You have to press equals first, so that it's down here on your screen, and then you press your bubble button to get the degrees, minutes, seconds. And we run And yeah, we're going to write all of that down. 34 degrees, 13 minutes. I think the last one was 48, wasn't it? Yes, yeah. 48. And the 2 lines per seconds. So circle per degree, 1 line per minute, and 2 lines per seconds. Let's do it again for the next one. There is. So, because this is a mixed numeral, 21 1/3, press Shift fraction button. Whoop, that didn't work. Shift fraction button to bring up the 3 boxes. If you don't do that and you just do a normal fraction and try to sneakily put the 21 in front, what's wrong with that? It won't work because your calculator times the 2 numbers together, which is not what you want. Okay, so I want the 3 boxes, 21 and 1/3. Press equals. Okay, it changed to a fraction, that's okay. But now I need to press my degrees, minutes, seconds button. And there it is, 21 degrees, 20 minutes, and 0 seconds. Question 3, we're going to go the other way. It says convert from degrees, minutes, and seconds back to just degrees. So you have to type these in with the bubble button. So every time you see a degrees or a minutes, you press the bubble button. So 34, press the button. 22, press the button again. I don't need the seconds because there wasn't any seconds for this question, so I can stop there. Press equals. Oh, there's no degrees, minutes, no seconds. To make it a decimal, what do you think I should press? What's the decimal button? How do you turn things to decimals normally? I tried that already. The SD, yes. Press your SD button. Oh, it went to a fraction. So I'm going to have to press Shift SD. I have to press Shift SD to get it down to decimal. So 34.8. It said 2 degrees. It didn't say how many decimals. Just press SD twice. Just press the SD again. Okay. Okay, let's just do 1 decimal place because I don't want to write all this down. So it'll be 34.4. And I'm going to put a degree sign at the end because that's all in degrees. Let's do the other one. So 50, bubble button, 25, bubble button, and 10, bubble button. Press equals, and then press your SD button a couple of times to get the decimal. No shift. So 50.4 degrees. Okay. It'll be all right. Okay. Question 4. This is practicing getting the theta by itself again. We have already done this, but here it is again. We're starting with sine theta equals 0.5. So the first bit of working out is done for us. We move the sign across the other side, which makes an inverse sign. And then our final answer we type in here. We go shift sine of 0.5 and we press equals. So the first one's equal to 30 degrees. But the other ones don't give me the helpful steps. I have to put those in. So for B, to get the theta by itself, I have to move the cos across to the other side, making an inverse cos of the 0.2525. Then I type that into my calculator by pressing Shift cos 0.2525. Again, I'm skipping the 0 because it saves time. To 1 decimal place, so 75.4. Okay, so quickly, can you do C and D? This is the second time we've done these. I'm hoping you can do these. Part C, move the tan across and then type in the calculator. Give it a go. Let's go. Let's go. All right, Riley, what is the answer to the first one? To one decimal place. How come? No, you don't press 10. I've said it 50 times. Maybe not that many. What do you press? Shift. Shift 10. So you get that little one. Shift 10. 1.555. What do you get? No. Riley, what do you get? 0.3. Good. 57.3. Good. Somebody else's turn for the next one. Okay. Which chair? What's happening? What's happening? Shift. Gotta get rid of the shift sign. It's not being true. Yeah, well, it is. That's what it is. We get 3.6. Good. That's why I want you guys to practice as we're doing it together, because otherwise you'll sit there and copy down everything I do, but not really understand what's going on. I need to be doing it with me. Question 4. Again, finding theta to the nearest degree. If I want the theta by itself, I have to move the tan across so that I'm doing inverse tan of 2.555. All right, type it in. Actually, what do you get? Just one. Oh, no, sorry. I should read the question. It says to the nearest degree. So I want no decimal places. So is it going to say 68 or should I go to 69? 69, because the next number is above 5, so it will round up. Okay, Sophie, how do I get that theta by itself for this one? Yeah, but what? See how this one happens? Inverse cos or shift cos. Okay, and who has an answer? But to the whole number, we don't want decimals this time. Just 75. Yep, because it says to the nearest degree means I don't want any decimals, I just want the nearest whole number. Okay, so that all of what we've done is just learning how to do stuff on our calculator, not really working out something that's meaningful. That's what's happening next. So question 5 is what you're going to be doing most of the time. We need to find the angles in our triangles, which means we've got to work out whether we're using sine or tan. Now, the labeling of the triangles was the same as last time. I had a little thought. So I know some of you are still having trouble with labeling your sides. Okay? So maybe let's try this. From your right angle, these two sides here that I'm highlighting in yellow, they are the two shorter sides. They are always going to be the opposite and the adjacent. We do need to work out which one's which, but they will always be the opposite and the adjacent ones. Which means the 17 is my hypotenuse. Okay, so it's not one of my highlights, 17 of my hypotenuse. Now, depending on the question, will depend on which one of these is the opposite, which one is the adjacent. The one that is the side that is next to the theta is going to be your adjacent. The other one is your opposite. Okay, so this one is going to be my adjacent, and the opposite is this one, but there's no number there, so I don't need that for this. Does that make sense? All right. So A and H means I'm using cos from my SOHCAHTOA. So I write my formula down. Cos theta equals adjacent over hypotenuse. Okay, my second line is going to be to sub the numbers in, just like before. But this time I don't know the theta. So the angle stays there as a theta. Cos theta equals. But I should have numbers for both of these. My adjacent is the 12, and my hypotenuse is the 17. So it will be 12 over 17. Now we are at the point of what we were doing in our calculator before. If I want to get the theta by itself, I have to move the cos across to the other side, making an inverse cos of that 12 over 17. And we type that in our calculator. So inverse cos, type in your fraction 12 over 17. Sorry? 45.1, perfect. Although, wait a second. It says up here to the nearest minute. Flip the page for me. These are the ones that say to the nearest degree. So I'm going to ignore this. It says to the nearest minute, but I'm just going to go to the nearest degree instead, because that's what you're going to have to do in your questions. All right, nearest degree. So the nearest whole number is just 45. No decimal places. I want the nearest whole number, 45. Okay, and that's it. That's what we're going to be doing over and over and over. Let's do it again. So next question, looking at my right angle, these two sides next to my right angle are going to be my opposite and my adjacent. And they're the two that I have numbers. So my hypotenuse over here is not important for this question. These two are. Now next to my angle is which is what it is, adjacent, between this one and opposite. So let's label them. Adjacent down here, opposite across there. Which one, sine cos or tan, uses the opposite and the adjacent? Tan, good, let's write the formula down. Tan theta equals opposite over adjacent. Second line, we still don't know what the tan theta is, but we're going to stub the numbers in the O and the A. O is 11 for the top, and A is 10 for the bottom. 11 on top, 10 on the bottom. Next step, get the theta by itself by sliding the tan across to the other side, which makes an inverse tan of 11 over 10, and type that into your calculator. To the nearest whole number. I don't want any decimal places. But after the 7, there's a 0.7, isn't there? So that means you're going to round it up to be 48. Good. Yeah?
Yeah, I don't know.
Yeah, always the whole number, nearest whole number for these. Okay, next one. Look at my right angle. There's my opposite and my adjacent sides. That means that this one over here is the hypotenuse. So let's put a H on that straight away. Now, the one next to, this highlighted one next to my theta, that should be the adjacent, but there's nothing there. So what's this one? Opposite. So I want the O and the H, which means sine. Sine theta equals O over H. Next line, sub in the O and the H. O is 15 for the top. H is 22 for the bottom. Okay, get the theta by itself by sliding the sine across, which is inverse sine of 15 over 22. Type it in. 43, excellent. Who said that? Good job. 43 degrees. Making sense? Is that the last one? It is the last one of ours. So your turn to practice.